Good morning everyone. Today we will do remainder theorem from polynomial. Okay, and it's very simple. We did how to divide a polynomial. Okay, in algebraic process in class 8. Okay, so actually that was a long division process. On that division we did dividend equals to divisor into quotient plus remainder. On that we can prove that. Okay, that long division process we did, but here we can calculate remainder by using the remainder theorem. Now what is a remainder theorem? Okay, so simple. Suppose p of x is a polynomial. Okay, p of x is a polynomial. Suppose this p of x is a polynomial of degree n and should be greater than or equals to 1. Then suppose a is any real number, and suppose this polynomial is divided by x minus a. Okay, then x minus a equals to 0, so x equals to a. So put x equals to a in p of x, that is p of a. Then this p of a will be the polynomial according to remainder theorem. Okay, now you see, I will write the statement. You write this way: let p of x be a polynomial of degree n, means highest power of the polynomial is n, and n is greater than or equals to 1. Okay, n should be greater than or equals to 1. And if a be any real number, then if a be real any real number and x minus a is and p of x, if p of x is divided by x minus a, then so x minus a equals to 0, so x equals to a. Putting x equals to a in here, p of x, then p of a will be a remainder. Okay, so this is actually the statement of the remainder theorem. P of x be any polynomial of degree n, and n is greater than or equals to 1, and if a be any real number, okay, and if p of x is divided by x minus a, then p of a will be a remainder. So this is the remainder theorem. Okay, by using this remainder theorem, okay, again important thing, same another theorem is there, that is called factor theorem. The remainder theorem will become factor theorem if the remainder will equals to 0. Okay, if your remainder will come 0, then that is completely divisible by the divisor. Okay, the dividend is completely divisible by the divisor. So on that case, the theorem is called factor theorem. Okay, for factor theorem, remainder must be 0. So this you have to keep in your mind. Okay, now you see NCERT 2.3 question number 1. Now from NCERT book 2.3 question number 1. 2.3 exercise from NCERT book 2.3 question number 1. Find the remainder when number 1. Find the remainder when x cube plus 3x square plus 3x plus 1, x cube plus 3x square plus 3x plus 1. Okay, 3x plus 1 is divided by number 1. First x plus 1, number 2 x minus 2, number 3 x, number 4 x plus pi, and number 5 plus 2x, 5 plus 2x. Okay, these are the question. When it is divided by this divided by this divided by this, on this way you have to find the remainder. So see, question number 1, I am doing this one. Okay, so let p of x, this is the polynomial, this dividend is the polynomial, x cube plus 3x square plus 3x plus 1. Okay, here degree is 3, so here n equals to 3, which is greater than equals to 1. Okay, it means greater than 1. So n is degree, so here degree is 3, so this is a polynomial, it is divided by x plus 1. Now you do like this, x plus 1 is equals to 0, then what is the value of x? Minus 1. Okay, then putting x equals to minus 1 in p of x, and then we will get the remainder. Okay, so now you replace all these x by minus 1, because we are putting x equals to minus 1. And why we are putting x equals to minus 1? Because in the question it is given that this polynomial should be divided by x plus 1. So I took x plus 1 equals to 0. Okay, then what is the value of x only? Then this plus will go, plus 1 will go on that side, will become minus 1. So putting x equals to minus 1 in the polynomial, this is the polynomial, that will give you the remainder. P of 1 is equals to minus 1. Sorry, this is minus 1. Okay, minus 1 cube, just replace all x by minus 1, plus 3 minus 1 square plus 3 into minus 1 plus 1. Okay, now you try to calculate this. What will come? I am rubbing this question. So now you see, p of minus 1 is equals to minus 1 cube, means minus 1 into minus 1 into minus 1, 3 times odd, so minus 1 will come. So this is plus 3 into 1, because minus 1 whole square, so minus 1 is plus, so this plus minus minus, 3 1 is 3 plus 1. So what will come here? See, minus 1 plus 3 minus 3 plus 1. It means that what is this? Minus 3 plus, okay, you do one thing, it is plus 2, this is minus 2, it is 0. Okay, so in first case remainder came 0. Okay, same way, same you see the p of x for question number 2. Question number 2 also same. Here x minus 1 by 2 equals to 0. So x equals to 1 by 2. So putting x equals to 1 by 2 plus 1 by 2 in p of x. You see that p of x. What is your p of x? X cube plus 3x square plus 3x plus 1. So this is p of half. X cube means 1 by 2 whole cube plus 3 1 by 2 square plus 3 1 by 2 plus 1. Okay, so now you see 1 by 8 plus 3 into 1 by 4, because 1 square is 1, 2 square is 4, plus 3 by 2 plus 1. Now you see this, now it is 1 by 8, means this is p of half. Okay, that is the remainder. So plus 3 by 4 plus 3 by 2 plus 1. Now you take the LCM. LCM between 8, 4, 2 is 8, no? 8. So 8 1 ja 8. So 1 into 1, 1. So 4 2 ja 8. 3 ja 6 plus 2 4 ja. So 4 3 ja 12. 1 8 times 8 1 ja 8. So what will come? 12 plus 8 20. 20 plus 6. This is 27 by 8. For this question number 2, remainder is 27 by 8. You can check. Now you see number 3. Okay. Number 3. Very quick. Only x is given. It means that x equals 0. So putting x equals to 0 in p of x. P of x is that dividend polynomial. So p of 0 equals to, you know that 0 cube plus 3 into 0 square, because I am replacing all the value of x by 0, plus 3 into 0 plus 1. It means that 0 plus 0 plus 0 plus 1 is equals to 1. It is plus 1. Okay. So this question 3.